Natural language processing, NLP, is a field of artificial intelligence that focuses on the interaction between computers and humans through natural language. The goal is to enable computers to understand, interpret, and generate human language in a way that is both meaningful and useful. NLP combines computational linguistics with machine learning and deep learning models to process and analyze large amounts of natural language data. This technology is used in various applications such as chatbots, sentiment analysis, language translation, and more. In NLP, the quality and diversity of data sources are crucial for building effective models. Data sources provide the raw material needed for training and evaluating NLP algorithms. These sources can include text from books, articles, social media, websites, and more. The richness of the data helps in capturing the nuances of human language, including slang, idioms, and context-specific meanings. Without high-quality data, NLP models may fail to perform accurately, leading to poor user experiences and unreliable results. There are various types of data sources used in NLP, each serving different purposes. Structured data sources include databases and spreadsheets, which provide organized and easily accessible information. Unstructured data sources, such as text documents, emails, and social media posts, offer a wealth of information but require more processing to extract meaningful insights. Semi-structured data sources, like XML and JSON files, fall somewhere in between, containing both structured and unstructured elements. Each type of data source has its own advantages and challenges. Public data repositories are valuable resources for NLP practitioners. These repositories offer a wide range of datasets that can be used for training and testing NLP models. Examples include the Common Crawl, which provides petabytes of web data, and the OpenAI GPT-3 dataset, which contains diverse text samples. Public repositories are often freely accessible and come with documentation that helps users understand the data's structure and content. Utilizing these repositories can significantly reduce the time and effort required to gather and pre-process data. Web scraping is a technique used to extract data from websites. It involves writing scripts or using tools to automatically collect information from web pages. Web scraping can be particularly useful for obtaining large volumes of text data for NLP projects. However, it is important to be aware of legal and ethical considerations, such as respecting website terms of service and avoiding excessive server load. Popular web scraping tools include Beautiful Soup, Scrappy, and Selenium, each offering different features and capabilities. Application Programming Interfaces, APIs, provide a convenient way to access data from various online services. Many platforms, such as Twitter, Reddit, and news websites, offer APIs that allow developers to programmatically retrieve data. Using APIs can simplify the process of data collection and ensure that the data is up to date. For NLP projects, APIs can be used to gather text data, metadata, and other relevant information. It is important to read the API documentation and understand any usage limitations or rate limits imposed by the service provider. Before using data for NLP tasks, it must be pre-processed to ensure quality and consistency. Common pre-processing steps include tokenization, where text is split into individual words or phrases, and normalization, which involves converting text to a standard format. Other steps may include removing stop words, stemming, and lemmatization. Pre-processing helps in reducing noise and improving the performance of NLP models. Tools like NLTK, Spacey, and TextBlob offer various functions to facilitate these pre-processing tasks. In a globalized world, NLP projects often need to handle multilingual data. This adds complexity to the data collection and pre-processing stages. Different languages have unique characteristics such as grammar rules, idiomatic expressions, and writing systems. To effectively work with multilingual data, it is important to use language-specific tools and resources. For example, the Polyglot Library supports multiple languages for tasks like tokenization and named entity recognition. Additionally, pre-trained multilingual models like BERT and XLMR can be leveraged for cross-lingual tasks. Ethical considerations are paramount when collecting and using data for NLP. Issues such as data privacy, consent, and bias must be addressed to ensure responsible use of technology. It is important to anonymize personal information and obtain consent when using data from individuals. Additionally, efforts should be made to identify and mitigate biases in the data, which can lead to unfair or discriminatory outcomes. Adhering to ethical guidelines and best practices helps in building trust and ensuring the integrity of NLP solutions. Data augmentation involves creating additional training data from existing datasets to improve the performance of NLP models. Techniques such as synonym replacement, back translation, and random insertion can be used to generate new text samples. Data augmentation helps in increasing the diversity of the training data, making the models more robust and generalizable. It is particularly useful when dealing with limited data or imbalanced datasets. Implementing data augmentation requires careful consideration to ensure that the generated data is realistic and maintains the original context. Pre-trained models have become a cornerstone in NLP, offering a way to leverage existing knowledge and reduce the need for extensive training data. Models like BERT, GPT-3, and Roberta have been trained on vast amounts of text data and can be fine-tuned for specific tasks. Using pre-trained models can significantly accelerate the development process and improve performance. These models are available through libraries like Hugging Face Transformers, which provide easy-to-use interfaces for integration into NLP projects. Fine-tuning involves adjusting the pre-trained model on a smaller, task-specific dataset. Evaluating the quality of data is a critical step in the NLP pipeline. Poor quality data can lead to inaccurate models and unreliable results. Key aspects to consider include data completeness, consistency, and relevance. Techniques such as data profiling and exploratory data analysis (EDA) can help in assessing data quality. Visualization tools like Matplotlib and Seaborn can be used to identify patterns and anomalies in the data. Ensuring high-quality data is essential for building robust and effective NLP solutions. To illustrate the importance of importing sources in NLP, consider a case study on sentiment analysis. Sentiment analysis involves determining the emotional tone of text, such as positive, negative, or neutral. For this project, data was collected from social media posts using APIs and web scraping techniques. The data was then pre-processed to remove noise and standardize the text. A pre-trained model was fine-tuned on the dataset to accurately classify sentiments. The success of the project hinged on the quality and diversity of the imported data sources, demonstrating their critical role in NLP. The field of NLP is constantly evolving, and new trends in data collection are emerging. Advances in web scraping technologies, the proliferation of APIs, and the development of more sophisticated data augmentation techniques are shaping the future of data collection. Additionally, the rise of synthetic data generation and the use of transfer learning are opening new possibilities for NLP projects. Staying abreast of these trends is essential for practitioners to remain competitive and innovative in the field. The future promises more efficient and effective ways to gather and utilize data for NLP solutions. In conclusion, importing sources is a foundational aspect of implementing NLP solutions. The quality, diversity, and relevance of data sources directly impact the performance and reliability of NLP models. Best practices include using a combination of structured, unstructured, and semi-structured data, leveraging public repositories, employing web scraping and APIs, and adhering to ethical guidelines. Pre-processing and data augmentation are crucial steps to enhance data quality. By following these best practices, practitioners can build robust and effective NLP solutions that meet the needs of various applications.